Hi everyone, myself Sindhu and welcome to my channel. Today we are going to discuss the topic of solid states. Before going to the topic solid states, let's first discuss about the basics. What are the basics? We have learnt in earlier classes that there are three states of matters called solids, liquids and gases. We know that liquids and gases are called as fluids because they have the tendency to flow. Why do they have the tendency to flow? Means in fact that molecules are free to move, hence they have the tendency to flow. And coming to the solids, the constituent particles of the solids are in fixed position and they can only oscillate about their mean position. Coming to the general characteristics which we have learned earlier itself, but it's very important. The characteristics are they have definite mass, volume and shape. They have definite mass, volume and shape. And the second characteristic will be the intermolecular distance. We know that intermolecular distance are very short and compactly closed. And the intermolecular forces are very strong. The intermolecular forces are very strong. What is intermolecular forces is nothing but the forces between the particles present. It's very strong. We know solids are very rigid and incompressible, and this was all about the general characteristics of the solid states. Now let's go to the types of solid states. There are two types of solid states, namely crystalline and amorphous. Crystalline and amorphous. First, let's go through the crystalline states. What are crystallines? As the name itself indicates, they are crystalline particles, and they usually consist large number of small crystals. They consist of usually large number of small crystals, each having definite characteristic geometrical shape. They have definite shape. They have the definite shape, and the arrangement of the particle is ordered and repetitive in 3 dimensions. Arrangement of the particles are ordered and repetitive. They are ordered and repetitive. They can also be called as the long range order. Long range order. What do you mean by this? Long range order is nothing but the regular pattern of arrangement of particles which repeats itself periodically over the entire crystals. Means if this is the structure of the particle, the same structure keeps on repeating for the next also. Keeps on repeating. Thus they are called as long range orders. Crystallines are also called as long range orders. And talking about their melting points, they have sharp melting points. They have sharp melting points. Means at a characteristic temperature they melt and become liquid. Abruptly they melt. And the nature of these solids are anisotropic. Here, what do you mean by anisotropic is nothing but the characteristics, like you can take physical properties, electrical resistance, refractive index. they show different directions in the same crystals. It may be a single crystal, they show differently in different directions. So only this is due to long range order. The difference in different direction is found only due to the long range order of the particle. So we have learnt now the characteristics of the crystalline solids. Now let's come to the amorphous solids. What are amorphous? Amorphous, generally speaking, they are powder like forms, and it has no regular shape. It's irregular. Its irregular shape means the arrangement of the particles are not repetitive, so they are also called as short range ordered. Short range order. We already discussed what is range of order, which is the regular pattern of arrangement of the particles is repeated. In the amorphous solids, it is not repeated. Thus, they are known as short range orders. And talking about their temperatures or the melting point, over a range of temperature, they get softened and then melt, and then they start to flow. These can also be molded and can be formed into various shapes. They can become crystalline also at some temperature. At some temperature, they can become crystalline. They can become crystalline at certain temperature. Even these amorphous solids have the tendency to flow like liquids, so they are also known as pseudosolids. Pseudosolids or supercooled liquids. Supercooled liquids. And talking about their nature, they are isotropic in nature. Properties of these like mechanical strength or refractive index, electrical conductivity, etc. are same in all directions. They are same in all directions. And this is due to the short range order. Means repetition of the pattern is for a short distance only. Thus, it is isotropic in nature. Now we have learnt about crystalline solids and amorphous solids. Now, besides of all these crystalline and amorphous solids, there are some solids which are apparently appears like amorphous, appears like amorphous. They appear like amorphous but have microcrystalline structures. But they have the microcrystalline structures. Thus, these particles or these solids are called as polycrystalline solids. These are also called as polycrystalline solids. Means it appears like amorphous but have the microcrystal structures present in it. Thus, they are also called as polycrystalline solids. Now, let's go with the classification of crystalline solids. Classification of crystalline solids. On the basis of the nature of intermolecular forces or bonds, the crystalline solids can be classified into 4 types. What are those 4 types are? Molecular solids, molecular crystalline solids also you can call it, molecular solids, ionic solids, metallic solids, and covalent solids. Let's go through it one by one. Now let's go with first one, the molecular solids. What are these molecular solids? You can think, the constituent particles of these molecular solids are, as the name itself indicates, molecules. Molecules are the constituent particles. In the molecular solids. And these molecular solids are later divided into 3 types, namely non-polar, polar, and hydrogen bond. What are these non-polar, polar, hydrogen bond? Let's go through it. First one, non-polar. Talking about non-polars and polars, in your earlier studies you have learned that there is no 100% covalent bond present. Based on that topic, this polar and non-polar bonds are present. Now we are talking about with non-polars. We can take the examples like H2, Cl2s and I2, means hydrogen, chlorine, iodine. The atoms are held by weak London force. Atoms are held by weak dispersion force or London force. Weak dispersion force or London force, you can call it. It's a weak forces. And talking about the nature of that solids, they are soft and the conductivity are, they are non-conductors of electricity. They are non-conductors of electricity. And their melting points are low melting points. And usually these solids are liquid or gaseous at the room temperature and pressure. Some may be solids, but mostly they are liquids or gases or gaseous state at room temperature. So now this much is about non-polar. Now let's come to the second one, the polar. According to polar, there is no 100% covalent bond. So you can give it an example like HCl, SO2 and etc. And these are formed by polar covalent bonds. These are formed by polar covalent bonds. And the molecules are held together relatively by strong dipole-dipole moment. Held by strong dipole-dipole interaction. Coming to these solids nature also, they are soft and non-conductors of electricity. Non-conductors of electricity, and their melting points are higher than non-polar molecules. Higher than non-polar molecules. Non-polar molecules are having low melting points, but the polar molecular melting points are higher than compared to the non-polar. That's it. And next we have the what is state they exist. What is the state they exist are gases or liquids under the room temperature and pressure. Some solids are also present. For example, for solids are, you can take SO2, NH3 as solids for the polar bond. And let's go to the third one, that's hydrogen bond. It is held by the polar covalent bonds between, it's a polar covalent bond. It's a polar covalent bond between hydrogen and fluorine or oxygen or nitrogen atoms. It's nothing but a bond between the hydrogen with fluorine or with oxygen or with nitrogen. And these are also non-conductors of electricity. Non-conductors of electricity. Generally they are volatile liquids. Volatile liquids are nothing but which gets evaporated at certain temperature. And they are also soft in nature under room temperature, and as they are volatile they can get evaporated also. You can take a best example like water. H is linked with the oxygen. Okay, and this was about the molecular solids. Now let's go to the second one, that's ionic solids. Ionic solids. As the name itself indicates, its constituent particles are ions. Constituent particles are ions. Constituent particles are ions, and they are formed by three-dimensional arrangements of, as it is anion, there involves cations and anions bound by strong electrostatic force. They are bound by strong electrostatic force. They are naturally, they are hard and brittle. They are hard and brittle in nature. They are hard and brittle. Their melting points and boiling points are high. Their melting points and boiling points are high. Since ions are not free to move, they are held by a strong electrostatic force. Thus, they are unable to move. They are electrical insulators in solid states. In solid states, they are insulators. Whereas in liquid, they are able to move. Thus, they can be a conductors. This was all about ionic solids, nothing more else. And coming to the metallic solids, here the constituent particles are nothing but positive ions surrounded by and held together. And they are held together by a free electrons. Free electrons. And these electrons are evenly spread throughout the crystals. As they are surrounding the positive ions, they are freely, evenly spread throughout the crystal. And these free electrons are responsible for high electric and thermal conductivity. Electrons are responsible for high electric and thermal conductivity. Of metals. This topic is not so difficult. It's nothing but the topic explaining that when you take a metal rod, for an example, when you take a metal rod, when heat is supplied at one end, when heat is supplied, after a few minutes you can find the heat transferred to the whole metal. This is due to the ion carrying the heat throughout this metal. That is the electrons responsible for high electric and thermal conductivity of the metals. And this is all about metallic solids, nothing more. And you know the nature of the metals, they are highly malleable and ductile. You know what is malleable and ductile? They are nothing but they can be drawn into thin wires or thin sheets. And some metals can be lustrous and color at certain cases only, and colored in certain cases. This was about metallic solids, nothing much more. And the last one is the covalent solids. Covalent solids. Here mostly variety of crystalline solids of non-metals results from the formation of covalent bond between the adjacent atom throughout the crystal. Such molecules are called as joint